Hi guys, here's the fifth video, I think. Now, so we're done with the general idea of functions. We've covered the basic types to start with. We covered polynomial functions already, and we've learned how to interpret the graphs. Operations on functions is the topic we just finished. Then also applying the concept of the domain and range on operations or functions. Now for the next topic, we'll be looking into another specific type of function. This one is rational functions. So you remember one part of our worksheets was you worked on rational equations. Oh wait, I'll be giving you the worksheet for rational equations and inequalities as well. But before that, let's cover these concepts first. So as a review, please um, by yourself work on solving rational equations. Here's just a review and some examples on how it's done. So rational equations will involve the LCD to simplify how it's done. And once we have um, removed the denominators or turned all denominators into one, then it's just the usual way of solving equations. The way we did linear, quadratic, and so on. So to start with, here are some examples. For 3 over x minus 1 half equals 12 over x, this one, then I have another function, another equation here, and this. So how are we going to solve these? So again, the idea is to make use of the LCDs. For the first one, the LCD is 2x. So multiplying that to all of the equation, left and right side, allows us to get rid of x and 2 in the denominators and come up with this linear equation right here. So we just solve for x in this case, so we end up with x as negative 18. Next. Here, we only have x plus 1 as the denominator, so that leaves us the LCD. Now, same idea, we multiply x plus 1 to every part of the equation. So we end up with this, 5x equals 4 times x plus 1 minus 5. Then this brings us to x equals negative 1. Now, this one, we cannot consider a solution. I'll ask why later. Third one, same idea. We have x minus 2 and x squared minus 4 as the denominators, but for its LCD, we have to recall how we factor expressions. So you have to be observant and be able to recognize factorable expressions because that affects your LCD. X minus 2 times x plus 2 is actually x squared minus 4. So by multiplying x plus 2 to x minus 2, we get our LCD. And this will be used to get rid of our denominators. Take note that as you multiply the LCD, take note of its factors and what will be cancelled out. Not everything from the LCD is cancelled out. As you'll see here, 3x minus 2 should be multiplied to x plus 2. And then 1 is multiplied to both x plus 2 and x minus 2. So we have this equation right here, bringing us this equation. It's quadratic in nature, so let's prepare solving quadratic equations, how you solve quadratic equations. X squared plus 2x minus 3 is the simplified form, and this brings us to the value x equals 1 and x equals negative 3. Now, do we consider these as solutions? Yes. But why is the second one not considered a solution? The value for x is negative 1. There is no solution because what does negative 1 do to the equation here, or to the denominator, to be more specific? Negative 1 plus 1 becomes 0. So again, if you remember our topic, we still consider the restrictions for specific function types. For fractions, we cannot have a denominator of 0. So if our um, if one of the values that we get after solving the equation turns out to be a restricted value, then you cannot consider it as part of the solution. That's going to be very important for rational functions, as you'll see later on. Now, jumping over to inequalities. Here, we follow the same idea, but for us to solve the inequality, one side should be 0, just like what we did with quadratic inequalities. So also, most of the cases here will rely on your factoring skills because we have to identify if the numerator and denominator can be separated into its factors. So just to show you this example, this inequality. Again, one side should be 0. So just have to move everything to the other side and consider removing the denominator. We end up with 6 minus x minus 24 all over 2x is greater than 0. And from here, we do have the value negative x minus 18 over 2x. So how do we completely solve the inequality? We consider the number line again. Just as I showed you last time in class, the number line will be divided into segments marked by what we call as critical numbers. What makes the factor 0? Negative x minus 18 and 2x are the involved factors. Negative 18 will be making negative x minus 18 0, while 0 makes 2x 0. Just imagine what do you call this? These sections here will again reflect the behavior of the factors for the set of x values in this number line. So if we're using negative 18, numbers less